Hello everyone. This video would focus on ellipses, and this is the first part. In this part, the example ellipse will have a center at the point of origin or at 0, 0. Now let's go over the two cases of an ellipse. So the first case that we have here is whenever the ellipse is elongated along the horizontal axis. So that's the horizontal axis right here, and the ellipse is all elongated along that axis. Well, the second case is whenever the ellipse is elongated along the y-axis. So these are the two cases of an ellipse. Now let's go over the parts of an ellipse. So let's take the first case of an ellipse whenever it's elongated along the horizontal axis. So this is the first part of an ellipse. So this is the major axis. In the major axis, this is where we can find the center. It's a center right here. So we will represent the center as HK. So I'm just going to label that down here. So that is represented as HK. And then we also have the focus and the vertex. So please remember that the focus and the vertex are actually located along the major axis. So there are two foci. So the plural for focus is foci. So there are two foci and there are two vertices. On the other hand, we have also what we call as the co-vertex and the other co-vertex right here. So these two are the co-vertices of this ellipse, and that this is the center of the ellipse. So these co-vertices are located along the minor axis. Now we remember that the distance from the center to the vertex, so that is coming from the center right here all the way to the vertex, we call this as our A. So this value that we have here is A. We are going to represent it as letter A. While the distance from the co-vertex to the center, we will represent this as letter B. And the distance from the center to the focus, we're going to represent this as letter C. So I'm just going to label that as letter C right there. Okay, now we always remember that for an ellipse, our A is always greater than B. So the value of A will always be greater than the value of B. The standard equation for this first case of the ellipse, whenever it is elongated along the horizontal line, we can represent the equation in standard form as x minus h squared over a squared, and that is plus y minus k squared over b squared is equal to 1. So this is the standard form of this ellipse. Now we also remember that the value of C that we have here, where we can locate the focus, we can solve the C using this equation, and that is actually C squared is equal to A squared minus B squared. Again, this is the formula that we're going to use to locate the focus, the distance from the center to the focus represented as letter C. Now let's move on to the second case of the ellipse. The second case is whenever the ellipse is elongated along the vertical axis. We can therefore say again that our center is represented as HK every time. So that's HK. And then the distance from the center to the vertex will be represented as letter A. So letter A doesn't have to be along the horizontal every time. It will always be along the major axis. So we represented this letter A, and then we are going to represent the value from the center to the co-vertex as letter B. So this one right here is letter B. And the distance from the center to the focus would be represented as letter C, or variable C. So we're going to write letter C on that one. We remember that in the major axis, we can find the two foci and the two vertices and the center of the ellipse. Well, on the other hand, on the minor axis, we can see the two co-vertices and the center. We also remember that for an ellipse, the value of A will always be greater than the value of B every time, no matter what. Now, if we represent the equation for this second case of an ellipse, we can go ahead and say that, again, we remember that the major axis here is the y-axis. So that is x minus h squared over b squared plus y minus k squared over a squared is equal to 1. And again, this is the standard equation for this second case of an ellipse whenever the major axis is the vertical line. So notice that we remember that A is bigger than or greater than B. So A is sitting in the denominator of Y. That tells us that the major axis is the vertical line. Now let's take some examples. So in this example, we're supposed to sketch the graph of the given ellipse below. So this equation right here, and we're supposed to determine the center, the minor axis, the major axis, the vertices, the co-vertices, and the focus. Now we remember that this equation that we have right here can be rewritten in a form that's gonna be x minus 0 squared over 169 plus y minus 0 squared over 25 is equal to 1. Using this equation right here, we can tell that our h and k are actually 0 and 0, and that represents the center of the ellipse. I'm just going to go ahead and write that down here so that a center is again represented as hk. That is, in this case, we have a 0 and a 0, so that is 0, 0. So the center is at the point of origin. The easiest way to look at this without having to change it to this form where we write the h and k is that whenever x is by itself without any number next to it, then we can go ahead and say that that is a 0. So that's a trick right there. So if there's no number next to it, so the center there is, that value is 0. And if there's no number next to the y, that value is 0. And so the center is at 0, 0. But I'm writing this general form right here so that when we get to the examples with h and k values, it will not be difficult for us to do. So our h is 0, our k is 0. That tells us that the center of this ellipse is at 0, 0. Now, looking at this, we compare the value of the denominators here, 169 and 25. 169 is bigger than 25, and we always remember that for an ellipse, A will always be bigger than B every time, no matter what. So this would represent as our A, and this would represent as our B. Now, on the other hand, we also remember that whichever is the bigger number, we look at it and we look at the letter on top of it, that's an X. So therefore we can go ahead and say that the major axis is the horizontal axis. I'm just gonna go ahead and write that down here. So our major axis is the horizontal axis. Again, the reason for that is because 169 is bigger than 25, and 169 is the denominator of the x, and the x would be representing the horizontal axis. So the major axis is the horizontal axis. We can therefore say that our A is the one that is always bigger. So that is A squared is equal to 169. And then we determine the value of A. So therefore A is plus minus 13. We can therefore tell that our minor axis is along the vertical line. So I'm just gonna write that down here. So that's the vertical axis, and this will be our B squared. So B squared is 25. We can tell that our B then is plus minus 5. And we also need to solve for C, and that is gonna give us an idea on where the focus is located. So we can go ahead and say that our formula for C squared is, again, that is A squared minus B squared. So that we go ahead and plug the values in. So that's 169 minus 25 is 144. So C is equal to the positive negative square root of 144. So then our C value is plus minus 12. So this will tell us the location of the focus. So then we are now ready to sketch the ellipse for this equation. So we always start with the center. So the center is at 0, 0. So we put this as the center. So I'm just going to label this as letter C. And then we also have the major axis is the horizontal axis. It's along this line. So we can find the two foci and the two vertices. So we can go ahead and say that since our A is 13 plus minus, so we can go ahead and go 13. So this goes by 2. So 2, 4, 6, 8, 10, 12, 13. So this is where the first vertex is going to sit. And that's negative 10, negative 12, negative 13. So this is where the other vertex is going to sit. So I'm just going to label this as the vertex, and this is the vertex right here. And then we go ahead and sketch the location of the B. So the B is plus minus 5. It's along the vertical axis. So that's going to be 5. So 2, 4, 5. It's going to be in between 4 and 6. And we do the same thing. 2, 4, 5. So then we are now ready to sketch the ellipse. So this is how the ellipse is going to look like. So I'm just going to go ahead and sketch that down here. So this is our ellipse, or the ellipse, or the graph of this equation that we have right there. So this is our co-vertex, and this is the other co-vertex. Now we say that the focus is located plus minus 12 from the center. So that is 0 here. So plus minus 12 would be this one right here. So I can go ahead and write the focus here. That's the first focus, and the other focus would be on the 12, and this is the other focus. So that we can go ahead and write this all up here. So we start with, we already determined the center, that's right there, is at 0, 0. The minor axis is the vertical axis. The major axis is the horizontal axis. The vertices would be, so I'm just going to go ahead and write that up here. So the vertices for these, for this ellipse that we have right here would be, this is the first vertex. So that is 13, 0. And the other vertex is located at negative 13, 0. We also have the co-vertices. So the co-vertices would be located at this point. So I label that up here. So that is 0, 5. So that's the first dot right there. And the other co-vertex is located at 0, negative 5. And the two foci are located on this points. So this is the first focus, and that is 12. This is 12, 0. And the other focus is negative 12, 0. Now let's move on to the next example. So in this example, we're supposed to sketch the graph of the given ellipse below. So this one right here, and we determine the center, the minor axis, the major axis, the vertices, the co-vertices, and the focus. So again, we are going to change this into its standard form with values for h and k. So I'm just going to go ahead and write that down here. So what I did was I added 0 to the h here, and I subtracted 0 to the representing the k right here. So we can go ahead and say that the center for this ellipse is at 0, 0. Again, we remember the fastest way is that if there's no number next to the x and there's no number next to the y, we always remember that the center would be at 0, 0. So then we can go ahead and look at the values for A and B here. So this is 9 and this is 25. We remember that for an ellipse, A is always greater than B. So in this case right here, this is our A and this is our B. Now we look at the variable that's on top of the A. So it's Y, so that we can go ahead and say that our major axis is the vertical line. So the reason for that is the The variable on top of the a is y. So y represents vertical axis. So that we can go ahead and say that our a squared here is 25. So that we can say that the a is plus minus 5. And so our minor axis then is the horizontal axis. So I'm just going to go ahead and write that down here. Since our b squared is 9, so then we can go ahead and say that the b value is plus minus 3. So that we go ahead and solve for c. Again, the formula is c squared is equal to a squared minus b squared. So I'm just going to go ahead and plug the values for a and b into the equation. Okay, so we already have a value for c plus minus 4. So we can go ahead and sketch the graph of this equation that we have up here. So we're going to start by plotting the center. So the center is at 0, 0. So I'm just going to label that as letter C. And then our major axis is the vertical axis. Now we remember that in the vertical axis, that's where we find the 2 vertices and the 2 foci. So the vertex is plus minus 5 from the center. So 1, 2, 3, 4, 5. This is our first vertex. And then that's a minus 5. So 1, 2, 3, 4, 5. This is the second vertex. I'm just going to label that as vertex and vertex. And on the minor axis, we can find the co-vertices. Vertices. That would be plus minus 3 from the center. So 1, 2, 3. So this is the co-vertex, and then 1, 2, 3, this is the other co-vertex. So that we can go ahead and sketch the ellipse for this equation that we have up there. So I'm just going to go ahead and draw that ellipse right here. So this equation that we have here will have a graph that looks like this. So that we can go ahead and determine where the focus is. It's a plus minus 4 from the center. So that's going to be from the, remember that the focus should be sitting along the major axis. And our major axis is the vertical axis. So that goes 4. So that's the first focus, and the second focus is going to be here. So that we can go ahead and sum up all the values for the vertices, the co-vertices, and the focus. So we have graphed the equation for this ellipse, and we have determined the center of the ellipse, the minor axis, the major axis, the vertices, the co-vertices, and the focus. That's it. If you find this video helpful, hit like and subscribe for more math videos. See ya!